Our final lesson is on Chapter 13, Lesson 3. It's on geometric probability. We're going to find probabilities of certain things happening by using length, so linear measurements, and then we're also going to find probabilities of certain things occurring by using the area of given objects. Lesson is not terribly long. We'll just go through a couple of examples. First, if you have a line segment, and line segment 1 would be AD, and it contains line segment 2. So line segment 2 would be BC in this example. So if line segment 1 contains segment 2, and a point on the longer segment is chosen at random, the probability that the point is chosen, that the point chosen is on segment 2 is the length of segment 2 over the length of segment 1. So we're just going to be setting up ratios. And we can turn those into decimals or percents as well, any of those options to show probability. But specifically for this example, if we choose a point at random on line AD, the probability that that point will be on BC is expressed by this ratio right here, BC over AD. So that's kind of the generic formula. What we're going to see is they'll give us measurements for these lines, and then we'll just have to figure out using numbers what the probability is. So a couple of examples here on this first page. We have line segment JM, and KL is contained on JM. So our first question, point X is chosen at random on JM. Find the probability that X is on KL. So we want to find the probability that of a random line chosen between J and M, or random point chosen between J and M, that the point falls between K and L. So we want to take, first of all, KL, that segment, and that length is 7, and then put it over the total line segment. So the total line segment is 3 plus 7 is 10, plus 4 is 14. So the probability that the point will land on KL is 7 over 14. Of course, simplify that, so that would be 1 over 2. Or we could express that as a decimal, or we could express that as a percentage. It's a 50% chance that it will land on KL. Another example, what is the probability? And here's how these are going to be written in your assignment. Just like this, probability that X is on line segment LM. So we want to take the shorter segment, which is LM, that's 4, and put it over the total. Does the total change? There you go, 4 over 14. And then simplify it, so it's 2 over 7. And finally, we'll look at this, the probability that X is on KM. So this segment. So KM, what's the total for KM? 11, and the total is still 14. That doesn't simplify, so we'd leave it just like it is. And that's all you have to do for this type of probability. There's a word problem here just to give you a little feel for what some of your problems might look like in your assignment. A train arrives or departs a certain train station every 15 minutes. So if you're standing at the train station, there's no way you'd ever wait more than 15 minutes because a train will either come in or depart during that time. And assuming you arrive at the train station at a random time, what is the probability that you will have to wait 5 or more minutes for a train? And we just kind of break this up into a number line. If you're standing at the train station and you're going to arrive at a random time during this 15-minute span, what's the probability that you're going to have to wait 5 or more minutes? So 5 or more minutes is shown by this part of the segment, B to D, correct? So if we take the segment from B to D, that is 10, and put it over the whole segment, that's over 15. And then just simplify it. So 10 over 15 simplifies to 2 over 3. And that's the probability that you'd wait 5 minutes or more for a train. Okay? The next thing we can do is we also can use area as probability. And if a region A contains region B, so the rectangle contains the circle, and point E in region A is chosen at random, so we're going to throw a dart at this board, it's going to land in a random spot, then what is the probability that E is in region B, or the random point is inside the circle? It's just going to be the area of the circle over the area of the rectangle. We have an example here. So what's the first thing that we need to do before we can figure out the probability?
You need to find the area of the two.
Need to find the area of both objects. So if we're going to choose a point at random inside the yellow rectangle, what's the probability that it also lands inside the white triangle? We've got to have the area of both objects. So the area of the rectangle is just 20 times 15, which would be 300. And then the area of the triangle is 1/2 base times height. That's 80 divided by 2 would be 40. So what do I do with these two numbers?
5.
Okay, what order?
5. D over A.
Triangle over this,
Triangle area
over the.
over the rectangle area. So 40 over 300. Simplify it. So that'd be 4 over 30, which would be 2 over 15. You have a 2 in 15 chance of
Getting in the triangle.
getting inside the triangle. We could also change that. If we change that to a decimal, what is it?
3.
0.13.
With the 3 repeating.
So 0.13, which would also be a 13% chance. Any one of those is appropriate for writing the probability. Okay? We also can calculate based on circle sectors. And so we want to find the probability of the pointer landing on this yellow section, which is represented by 45 degrees. So how does that, knowing the degrees, how does that help us find the probability?
Because 45% of 360.
Close, not 45%, it's 45 degrees out of 360 degrees. So 45 over 360. We could simplify that, or we could just turn it into a percentage.
It'd be 45%. What is it?
1/8, so it simplifies to 1 over 8. And as a percentage, that would just be 12.5%, right?
Yeah.
So a 1 in 8 chance or a 12.5% chance of landing inside the yellow area. How about the probability of the pointer landing on the purple?
70 that's purple.
Yeah, I know, right? It looks maroonish, I guess, on the screen, but it's supposed to be purple. So 105 over 360. Let's just change it to a percent. So 105 divided by 360.
29%.
It's a 29% chance. All right, and then this one's worded a little differently. So the probability of the pointer landing on neither red nor blue. So it's not going to land on these two. It can land anywhere else. So what do we have to do? Have to add all these up, right? So 105 plus 90 is 195. Plus 45 would be 240. So 240 over 360, and give me the percentage there. So about 67%, right? 66.7%. So that's probability based on area and based on linear measurements. Very similar probably to the probability type problems you've done before, but just kind of a little different way of looking at it with linear measurements and area measurements. Your assignment today is a worksheet, so I'll get that to you.